All right, welcome back. We just finished talking about the Pythagorean theorem, and the Pythagorean theorem is really great. It works only in a right triangle, remember, but it will help you find a missing side of a right triangle if you know two other sides. So we're going to now get into what we call trigonometry. Now, let's start off before we tell you why we need trigonometry. Let's just define what is trigonometry. Trigonometry is just as easy as this. It's just the study of triangle measurement. Triangle measurement. Now, in triangles, you can measure sides, so it will help you with finding side lengths. You can measure angles. It can also help you find angle measures. But it's just helping you find missing bits of information in a right triangle. So with the Pythagorean theorem, you have to know two sides to find the third side. With the right triangle trigonometry we're going to be doing this unit, you're going to be able to find sides knowing just maybe one side and one angle. You're still going to need to know two bits of information, but this trigonometry will help you to be able to find other measurements. So before we get into solving triangles, this whole unit is just about what we call ratios. Now, remember from our similarity unit, a ratio is just comparing two sides to each other. So we have some special trigonometry words that are going to be used to help you to compare sides together. So before we start right here, well, actually, let's go ahead and start. So the sign right here, it looks like sine right here. They will shorten it on a calculator. You will see it written as just the sin. It's not sin, it is a sine. Okay, the sine is always going to be the ratio of the opposite side of the angle that you're talking about to the hypotenuse. So when you're looking at this lovely triangle, we're going to talk about angle A first. Okay, so we're going to go through and find all of our angle A's, and then we'll redo it for angle B. So what I would do when I'm looking right here at angle A, there's a nice lovely mark called theta. It's a Greek letter. It's theta. It's spelled Theta. But theta is just kind of, it's how we say that's the angle that we're talking about. So we're going to put it right here with angle A because that's what they're going to ask us for right here. Now on all three of these lovely trig ratios, the sine, what we call the cosine, and the tangent, to be able to find these, we have to label our triangle. All right, and so you're going to label your triangle with words like hypotenuse and words like opposite. And our last side we're going to call the adjacent side. All right, so those three words. Now I'm going to just kind of pull those down. The hypotenuse is the easy one. Hypotenuse, remember, if you go to your right angle, the hypotenuse is always across from it. It's always going to be your longest side. It's always C, but it's across from that right angle. Now the opposite, this one could go either here or here, depending on which angle you're talking about. So right here, where we're talking about angle A, right here, when we find the opposite, you're just going to go straight across from that angle, and that side's your opposite. And that leaves, I always do the adjacent last. Okay, so because there's really two sides that are adjacent to that angle, but one will always be the hypotenuse right there. All right, so we now have these nice, lovely sides labeled. So this sign right here, let's go back to get a marker. The sign is always the opposite over the hypotenuse. So it's just going to be the opposite over the hypotenuse. So when you look right here, my opposite was A. So it's going to be A over the hypotenuse, which was C. So it's just A over C. That's what your sine is. All right, now your cosine is going to be the adjacent over the hypotenuse. Okay, so the adjacent over the hypotenuse. Again, you're just going to look at what you labeled. So we labeled the adjacent side B. So it's going to be B over the hypotenuse, which is still C. And then our last ratio, the tangent here, the tangent is the opposite side over the adjacent. So opposite over the adjacent side. So in this lovely triangle, my opposite is A, my adjacent is B, and so that's the tangent of B. All right, so that's how you find the ratios. Now, please note, this is the most important thing that you could do is label your triangle correctly. So Please spend some time to kind of learn these. I'm going to show you a little hint here in just a minute. But before we do that, we're going to go back. They've also asked for the sign of B. So we're now going to take our angle right here, and we're going to move it. Say we want to now talk about this triangle in relationship to angle B. Note that this side is still your hypotenuse. My right angle didn't change, so that's still my hypotenuse. However, my opposite, this is no longer opposite. We're going to have to put the opposite over there and then move the adjacent down to there. So the adjacent and the opposite move when you switch angles, and that's it. All right, so now when we go through to talk about the sine, again, our sine is our opposite over our hypotenuse. So now when we look for our opposite, it is B over my hypotenuse is still C. Okay, the cosine of angle B is the adjacent over the hypotenuse. My adjacent here was A over my hypotenuse, which was C. And then our last one, the tangent, remember, is the opposite, or the O over the A, the opposite over the adjacent. So B over A is going to be our tangent of B right there. All right, now here is a fancy way to remember this. They've kind of given us this nice, lovely acronym, I guess, if you will, but it's SOHCAHTOA. Okay, so I just write it out, SOHCAHTOA, and I'm going to be saying this a million times every lesson. So hopefully you'll get this really soon and that you'll even be able to spell it. But SOHCAHTOA stands for this. It says the sine of an angle. So there's my S right here. The sine of an angle is, now remember the sine was the opposite over the hypotenuse. Look, there's my O first and then my H. So it's the opposite over the hypotenuse. Okay, so the sine is the opposite over the hypotenuse. The cosine of an angle, and again, I just called it theta right there. So the cosine of theta is A, which stands for the adjacent, over H, the hypotenuse. And then our last one, the tangent right here. The tangent of theta, the tangent of our angle, is always going to be O, or the opposite side, over the adjacent. All right? So please note, you're going to want to memorize this, make up a song for it, something, but SOHCAHTOA, we're just going to say SOHCAHTOA, SOHCAHTOA a million times. So that's just kind of an introduction, and we'll go through all of the examples in their own video.